Okay, folks, so we want to look at properties of logarithms and if we have room, the exponential functions. But let's start off with, first of all, just the definition of logarithms. So we're familiar with a statement that maybe looks like this. If we have a to the m, and say that equals n, so here we've got some sort of exponential equation. This is true if and only if, and so here's our definition for logarithms, if the log base a of n is equal to m. Okay. So for example, let's first put up just a couple of examples. For example, if we say that let's say 5 to the third power is equal to 125, that's an exponential statement. And so its equivalent logarithmic statement would be something like this. Well, in fact, listen to how we read this. We said base 5 to the third power is equal to 125. We call this the base. So when we go to talk about the logarithmic statement, it's going to be that log base 5 of 125 is equal to 3. So again, when you're just looking at the log base 5 of 125, that's saying 5 to what power will return 125. So 5 to what power returns 125? And the answer is 3. So that's how we can convert back and forth between logarithms and exponentials. So at some point you've developed some of the properties of exponential functions, and the properties of logarithmic functions are related to those. So I'm just going to go ahead and give the corresponding properties. We will say that or this is a fact, that the log base a of m times n is equal to the log base a of m plus the log base a of n. And we'll give the next one, it's really not a different property, but the log base a of m divided by n, that's equivalent to the log base a of m minus the log base a of n. And then finally, and I'm running out of room here, but if we say the log base a of m to the r power, that's equal to r times log base a of m. So I put these three properties up here. Let's just talk about them for just a moment. This first one's saying that, hey, if you have multiplication occurring inside a logarithm, that's equivalent to addition outside of the logarithm, or vice versa. So if I'm adding two logs together of the same base, I can combine them into a single logarithm if I multiply their arguments with inside the logarithm. Let's clean that up. This next fact says if we have the argument of a logarithm is being raised to a power inside that logarithm, we could factor that out. So we say that powers come out of logarithms as factors. Okay. So I'm going to do a couple of these, but I'll let you fill in the details. You should have done a lot of this before, but this will hopefully serve as a nice reminder. So I'll do the first one of each one of these and leave you to do the rest. So here we say, hey, 3 to the fourth power is equal to 81. So what's the equivalent logarithmic fact? Well, the equivalent logarithmic fact is that the log base 3 of 81, we'll see, that asks the question, 3 to what power is 81? And the answer is 4. Okay. So I'll let you fill in 3 and 4 and 5 here. Okay. Now, a couple of notational issues. For the exponential equation e to the a equals b, you would expect to write, well, you'd expect to write the log base e of b is equal to a, and that's a perfectly good thing to assume it might be. But in fact, we write that the natural log of b is equal to a. So rather than writing, what I'm saying here is rather than writing log base e, we write natural log. So let's look at this statement here. Given that e to the third power is approximately 20, write an equivalent logarithmic approximation. Well, that would be that the natural log of 20 then is approximately 3. We have one more of those little surprises, and that is for the exponential equation 10 to the a equals b, you would expect to write it as the log base 10 of b equals a. Instead, we're just going to write the log base 10 of b equals a. So notice that when I said that, we have the log base 10, and I didn't write a base there, but when no base is given, at least for scientists and engineers, the base is understood to be base 10. Okay? So I know that this fits with the way we've given the definition for how to write out a logarithm, but this is sort of a shortcut. So it shouldn't be too surprising to you that we do this sort of notational shortcut. You know, if you see the cube root of x, to say that it's a cube root, I have to put the index of 3 there. But if I want to talk about the square root of x, I won't put a 2 there. There's an understood 2 for the index when I do a square root. The same thing is true then with logarithms. There's an understood base 10 there, and that we don't write when we're talking logarithm base 10. Okay, so I'll let you fill out the rest of these.